Good morning, students. Your teacher here, Mr. Surasinski, with another episode of Geometry. This is lesson 3.3, Proving Lines Parallel. And we have learned about the different angle relationships created by transversal and parallel lines. And now we're going to use those angle relationships and kind of work backwards and say, okay, we don't know that these lines are parallel, but if the angle relationships are true, then the lines have to be parallel, okay? So we have our four methods for proving lines parallel here. And here we go. Let's jump in. So the first is corresponding angles converse. So the converse is like well, let me just read it and I think it'll make sense here. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So now instead of saying if the lines are parallel, then the corresponding angles are congruent, we can say if the corresponding angles are congruent, then the lines are parallel. So the first example we would say, and this is using this diagram up here, if angle 1 is congruent to angle 5, then line L is parallel to line M. Okay. Alternate interior angles converse. If two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So we can say, again, using that diagram above, if angles 4 and 6, angle 4 is congruent to angle 6, then line L is parallel to line M. Alternate exterior angles converse. If two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. So we could say if 2 and 8 are congruent, if angle 2 is congruent to angle 8, then line L is parallel to line M. And then lastly, consecutive interior angles converse. If two lines are cut by a transversal so that consecutive interior angles are supplementary, which means they add up to equal 180, then the lines are parallel. So this would be like 3 and 6 or 4 and 5. So we could say if angle 3, if the measure of angle 3 plus the measure of angle 6 equals 180, then line L is parallel to line M. Okay. So those are our four converses, and that's what we're going to be using today to prove lines parallel. When we get an angle relationship, we'll have to determine what is the transversal, and then which lines did we prove parallel. Okay, so here we go. Practice. Given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. Okay, so let's go ahead and get started. Part A, angle 2 and angle 4. Okay, so angle 2 and angle 4 are congruent, and angle 2 and angle 4 are corresponding angles on transversal A, which means that the lines that we just proved parallel are C and D. And this is the corresponding angles. Converse, okay? Angles 5 and 10. 5 and 10 are alternate interior on transversal C, which means we just proved lines A and lines B are parallel, and that would be alternate interior. Okay. The measure of angle 6 plus the measure of angle 10 is equal to 180. 6 and 10 are consecutive interior angles on transversal C. So we just proved angle or line A is parallel to line B. That's consecutive interior. Okay. Angle 1 is congruent to angle 14. Angle 1 and angle 14, those are alternate exterior on transversal C. So we just proved A is parallel to B, and that's alternate exterior, converse. Okay. The measure of angle 14 and the measure of angle 15 is equal to 180. Those are consecutive interiors on transversal B. So that proves line C is parallel to line D, and that's consecutive interior. Okay. Angle 11 is congruent to angle 16. Angle 11 and angle 16 are vertical angles, but vertical angles is not one of our converses, so that does not prove anything. Okay, angle 4 and angle 15 are alternate exterior angles on transversal D, so that proves line A is parallel to line B, and that's alternate exterior. Okay. Angle 10 and angle 12 are corresponding angles on transversal B, so that proves line C is parallel to line D, and that's going to be corresponding angles. Okay. Measure of angle 9 plus the measure of angle 13 equals 180. These are a linear pair, but they are not consecutive interior, so this is not one of our converses. So none. Angle 2 is congruent to angle 7. Those are alternate interior angles on transversal A. So it proves that line C is parallel to line D. And those are alternate interior. Okay. And then last but not least, angle 6 is congruent to angle 11. Angle 6 and angle 11, those are on different transversals. So that is not one of our converses. Okay, next page. All right, so here we go. Example 2, a little bigger diagram here, but it's not a big deal. Angle 9 is congruent to angle 22. Angle 9 is congruent to angle 22. Okay, so those are on transversal S, and those are alternate exteriors. So like if we're ignoring this upper parallel line, those are alternate exterior. And they prove that line Q is parallel to line R. Okay. All right. The measure of angle 8 plus the measure of angle 13, 8 and 13 equals 180. Those are on transversal T and prove that line P is parallel to line Q. Those are consecutive interior. Okay. Angle 1 is congruent to angle 17. Those are on the same side of the transversal. So if we were ignoring Q, those are on the same side of the transversal in the same position, and they're on transversal S. So that's going to be corresponding angles, and that proves that P is parallel to R. It's corresponding angles. Okay. All right, and sometimes you got to mark out one of the parallel lines just to really get an idea of what it is. It's a little tricky in this diagram. Angle 16 is congruent to angle 20. Those are alternate interior angles on transversal T, and that proves that Q is parallel to R. Those are alternate interior. Okay, angle 5 and angle 24 are alternate exterior on transversal T, and that proves that P is parallel to R. It's alternate exterior. Okay, the measure of angle 4 plus the measure of angle 17 is equal to 180. Those are consecutive interior angles on transversal S, and that proves that line P is parallel to line R. Consecutive interior. Okay, angle 10 and angle 13 are congruent. Those are on different transversals, and so this is nothing. Okay, they can't be on different transversals. They have to be on the same transversal. Angle 3 and angle 22, those are corresponding angles on transversal S, and so that proves that line P is parallel to line R, and they're corresponding angles. Okay. Angle 5 and angle 15 are also, let's see, 5 and 15. Those are alternate exterior on transversal T. So that proves that P is parallel to Q. Alternate exterior. Okay. And then the measure of angle 11 plus the measure of angle 16 equals 180. Those are consecutive interior. Nope, those are on different transversals. It's on transversal S and T, and so that is none. All right, so complete the proof below by filling in the missing reasons. All right, so here we are given proofs, and you guys will be working on these later, not in this little introduction that we are doing here at the end of algebra, but when you get into geometry, you'll be working on proofs. And we're actually already given the statements. All we have to do is provide the reason. And so basically we're proving, given a list of information, that lines are parallel. So if angle 4 and angle 5 are supplementary, then that is the given. Okay, that's the information that we're given. Okay, we didn't have to prove that or give a reason. The measure of angle 4 plus the measure of angle 5 equals 180. That is the definition of supplementary. And since angle 4 and angle 5 equal 180, then we can say that these lines are parallel based on the converse of consecutive interior angles. Okay. All right, number 4. Angles 1 and 2 form a linear pair. That was given. Angles 1 and 4 are supplementary. That was given. Linear pair, the definition of a linear pair is that they're supplementary. And so this is the supplementary theorem. Okay, and we saw that when we were learning about the different angle relationships. And then angle 2 is congruent to angle 4. And that is the congruent supplement theorem. And so we can say that since angle 2 is congruent to angle 4 based on the congruent supplement theorem, we can say that line A is parallel to line B based on the converse of corresponding angles. Okay. I am your teacher. I know these last couple little proofs might have been a little confusing, but don't sweat it. Okay, you'll get the hang of it as we do a few more later on. I am your teacher. This is the way.